Solving radical equations. Solving radical equations has 4 steps to it. Now I know as students we like to always skip the last step, but actually in this case it's the most important step. So don't skip any of them when we're solving radical equations. The first step in solving radical equations is to isolate the radical. So if you have a square root, you want it all by itself on one side of the equal sign, everything else on the other side. It does not matter if the radicand is just a single term or if it's 2 terms or 3 terms. Still, that entire radical expression has to stay on one side. Remember, you can't change over if you do have 2 terms underneath the radical. Keep that in mind. We'll talk about that in one of the examples. Okay, so isolate the radical. Step number 2, well, the reason that we can't solve a radical equation is because of the stupid radical. We don't understand that exactly. So we're going to get rid of it. A radical is a square root. It cancels out a square, which means that a square cancels out a square root. They cancel each other. So the second step is to square sides. Square both sides. You cannot square individual terms. Whether it's underneath the radical or outside, it's squaring both sides of your equal sign. After you square both sides, you'll get rid of the radical, and so now you have an equation that you can solve. The remaining equation will either be linear, which means that you just have x to the first, and you get x on one side and everything else on the other side. Or it might be quadratic, meaning that you have an x squared. That's what we did back a couple weeks ago. You'd have to then set the equation equal to 0, factor the trinomial, set your factors equal to 0, and solve. Okay, so that same procedure of solving that we did in the chapter on factoring keeps coming back. It's using that zero product property, my favorite property. Okay. And then after you solve though, here is the key. The one thing that we don't like to do, but we have to do with radicals, is check the answer. We might get 2 answers and maybe one of them doesn't check. Maybe neither of them checks. Because maybe we did some illegal math. When we squared, maybe there was a negative that we introduced. Okay? We have to take that into consideration. So those are your 4 steps for solving a radical equation. Let's go through one. Here's our equation. 3 plus the square root of the quantity x minus 1 equals 5. Remember, you're taking the square root of this entire quantity. Our laws said if we had multiplication or division, we can separate these. We don't have that. We have subtraction, which means that we cannot separate the radical, or the radicand. We can't take away that 1 from the x. A radical is is an assumed set of parentheses. What's underneath the radical has to be done first, and then you take the square root of that when you are simplifying. Because we don't know what x is, we can't take 1 away from it, so we can't proceed in that fashion. That's why we have to do other things to solve this equation. So, step number 1, isolate the radical. Is the radical, which is this entire portion, the square root of x minus 1, is that by itself? No, we have this 3 over here. So the first thing that we have to do is move the 3 to the other side. To move from one side of the equal sign to the other, we do inverse operations. It's a positive 3. The inverse of a positive 3 is a negative 3, or subtracting 3. So you do the same thing to both sides. 3 minus 3 cancels. You're left with the square root of x minus 1 is equal to 2. So that was step number 1, isolate the radical. Step number 2, now that the radical is isolated, we want to get rid of it. So in order to do that, we square. When we square both sides. So this entire side gets squared, this entire side gets squared. The square cancels with the square root. That's why we do it. Those are inverse operations of each other. They cancel each other out. So a square cancels with the square root, leaving the radicand behind. And on the other side, 2 times itself is 4. Now we have a linear equation that we can solve. We solve this by, once again, getting your variable by itself. It's x minus 1. To cancel out subtracting, we add 1. Whatever you do to one side, you do the same operation to the other side. So we get x is equal to 5. Let's see here. This was step 2. This was step 3. Now the key step. We have to check our answers. So now that we know that our answer is x, the value of x is 5, we go back into the original problem before we do anything else to it. That's where you have to check and simplify. See if the left side equals the right side. So I'm just going to rewrite that equation down here. And now I know that x is 5, so where there's an x here, I'm just going to replace that with 5. Just replacing, I know that x is the same thing as 5, so where there's an x, I replace it with 5. Now we simplify using our correct order of operations. Like I said before, a radical is like an assumed set of parentheses, so we have to simplify what's inside here first. 5 minus 1 is 4. You still have the radical sign. We haven't done anything with that. Now that it's just a single value under there, I can simplify. What is the square root of 4? What number times itself is 4? Well, that's 2. And now you can simplify 3 plus 2. Yep, that's 5. 5 equals 5. It checks. So this is just the check, telling us that this is our answer, and our answer works. Let's try another. Here's another problem. The square root of the quantity x minus 3 is equal to x minus 9. Now fortunately for this problem, our radical is already isolated. Square root of x minus 3 is already by itself on the left side. Doesn't matter which side, as long as it's all by itself on one side. So now I can go straight to step 2. Square both sides. So I'm squaring this side, and I'm squaring this side. On the left side, the square and the square root cancel each other, as those are inverse operations, leaving us with just the radicand of x minus 3. On the right side, however, this is the key thing to remember. Very important to remember this. You cannot bring a square inside with addition or subtraction. Our exponent laws from chapter 4 say if there is multiplication or division, you can bring an exponent inside, not addition or subtraction. You need to remember what the square means. The square is on the outside of the parentheses, meaning what's inside the parentheses is taken times itself. So to write that out, it's really indicating that we're taking x minus 9 times x minus 9. And in order to multiply polynomials, you take each term of the first set and multiply it to every term in the second. We also know that as the FOIL method. So you will need to do that in your next step. So if you have an extra variable here, you're going to have to FOIL. Your outside was a negative 9x, your inside is a negative 9x. 9 and 9 makes a negative 18. Negative 9 times a negative 9 is a positive 81. So now we have an x squared. In order to solve this, we have to have the equation set equal to 0. You cannot use the zero product property if your equation is not equal to 0. So our next step is to subtract x, and we may as well do 2 steps in one. We will also add the 3. Now, be careful here. We like to just get a little bit lazy. You need to remember, we started with an equation. This is a balanced. The left side equals the right side. Since we have this balance, you still have the balance through the entire problem. So even though we cancel things out, they become 0. X minus x is 0. Negative 3 plus 3 is 0. You get 0 on that side. Don't lose the fact that you have two sides of an equal sign to represent this equation. Then the x squared, there was no terms like the x squared, so that comes down. Negative 18x minus x is a negative 19x. And 81 plus 3 is 84. Our next step is to factor. Still have the 0, because remember, the zero product property says I need to have a product or multiplication equal to 0. Fortunately, this is the easier kind. What times what is x squared? Well, that's going to be x and x. The positive 84 here tells me that both of my signs have to be the same. Since they have to add to a negative, they both have to be negative, because a negative times a negative will give me that positive. Now I need to think of factors of 84 that add up to 19. Well, the first thing I think of is the fact that I have an 84-inch couch, which is 7 feet. So 7 times 12 is 84. We don't call it a couch, we call it a Davenport, I guess. So 7 and 12 multiply to give me 84. Oh look, 7 and 12 ends up adding to 19. So 7 and 12 are the two numbers. So now we can use the zero product property, which states if I have two numbers multiplied together equal to 0, either x minus 7 equals 0 or the x minus 12 equals 0. Now we have two small linear equations that we should be able to solve. X minus 7, to get the x by itself, we add 7. Show all of these steps, because otherwise we have the tendency to say, oh, x is negative 7, and it's not, it's positive. Or, same thing over here, add the 12, x equals 12. So we have these two solutions. But wait, we're not done, because we have to check our answer. Let's go back into the original, always into the original. Okay. And let's check the x equals 7. So I'm just going to replace all 7's, or all x's with 7. So I have 7 minus 3 is equal to 7 minus 9. 7 minus 3 is 4. 7 minus 9 is a negative 2. What number times itself is 4? Well, that's 2. Does 2 equal negative 2? No. Bad guy, evil Lynn Skeletor, man in black hat, x equals 7 does not work. It doesn't check. Because when we find a square root, we're always looking for what they call the principal root, which is positive. So that one does not check. Let's check the 12 quickly before I run out of time. 12 minus 3 is equal to 12 minus 3 is 9. The square root of 9 is 3. 3 equals 3. That one checks. So x equals 12 is the only one that checks. X equals 7 does not check. It's called an extraneous solution. Extraneous solution, and does not check. That's why it's so important that you check all of your answers when solving radical equations. One or both may or may not check.